Hello friends and welcome at my channel. Today I would like to prove three more limits. They are just about sine of x divided by x or something comparable to this. So let's start with the first one where we are computing the limit x towards a, cosine of x minus cosine of a, and we are dividing over x minus a. Okay, so this is familiar to what we've been doing in the last video with the sine. And we just have to apply one more formula from trigonometry here. So that would be the limit again, x towards a, and then we're getting 2 sine of x plus a divided by 2 times the sine of a minus x divided by 2. I could write x minus a, but then I have to kick minus in front of the limit or in front of the 2. I don't want to do this. That's why I'm writing a minus x divided by 2 over x minus a. I hope you can see that. Once again, if you want to prove, just do it. I've done it in the last video. I link it here. And I've done it with the cosine. Now it's the same for the sine, okay? You just solve the parentheses, you multiply it out, and you'll see that it works. I won't do it here again. I think it's clear that it works. You can check it yourself. If you have questions, write, I'll answer. And what we're going to do now, well, we would like to still have maybe x minus a or a minus x. Well, you see, I think I wrote x minus a, so it doesn't matter actually. All right, so what we're doing here is we are trying to get the same result as we have with the sine. So I'm switching the signs here, and I'm also dividing by 2. So I'm multiplying times half divided by half. So this is 1, not changing anything. I'm getting to a limit x towards a still. We have no 2 anymore. We have just sine of x plus a divided by 2 times sine of, well, you see, I wanted to have a minus x, I still have it. But here I'm having a minus x I would like to have now, a minus x. So I switch it. I have times a half, and now I have minus in front. All right, because I switched the order, I had x minus a. Now I'm having a minus x. I'm kicking the minus. And now you see, as x is approaching a, this limit is approaching 0. This value as well. So this is sine of a minus x, kind of sine of 0 divided by 0, and we know it's 1. So basically we can split it into two limits. Have limit x towards a of sine of x plus a divided by 2 times the limit of x towards a sine of a minus x divided by 2 divided over a minus x divided by 2. Don't forget the minus, which I forgot. So that gives me 1. And now if x is approaching a, we have a plus a is 2a divided by 2. So it's just a minus sine of a. It's pretty nice because actually we've been dealing with the cosine values. And now you see we're ending up at minus sine of a. Right? Okay, let's move on. Let's do one more example with the cosine. So we have a limit. Now x is running towards 0. And now we're having the cosine of mx minus the cosine of nx divided over, we got x squared. So what we're doing here, we're applying the same formula we've been dealing previously. So x towards 0, we have, now you see, 2 sine of, we've been having mx plus nx divided by 2. And now we are having here, it was times sine of And now I switch the order once again. It's nx minus mx divided by 2 again, divided over x squared. All right? So now you see we can take x is in front. We can write it as limit x towards 0. We can kick 2 outside of the parentheses. So we are having here, look at this, sine of x times m plus n divided by 2 divided by x times sine of x times n minus m divided by 2 divided by 1 more x. And now you see if x is approaching 0, we have once again, so we don't worry about this fraction, this is some value, but we're having x divided, sine of x divided by x as x is approaching 0, so it's 1. And this one is 1 again. So now maybe you see what's happening here. So what I'm trying to do now, I'm firstly splitting those two limits. So I still have 2. I have limit x is approaching 0. Now you will see what we're doing. We are having sine of x times m plus n divided by 2 divided over x, and I would like to borrow m plus n divided by 2, which I didn't have. So I have to multiply times the reciprocal here so that I'm not changing anything. Now what we have is times, so this is the first limit, times the second limit, x towards 0 still, we have the sine of x times n minus m divided by 2 divided over x times, and now I'm multiplying times n minus m divided by 2 times 2 divided by n minus m. So this is the second limit. Now you see maybe what's happening. So this is a constant. Division by that means I'm multiplying times the reciprocal, so I'm still having 2. I'm having m plus n divided by 2. The limit is giving me 1. Now what's happening here, I'm having n minus m divided by 2 here, and this is one more limit which is giving me 1. So I can cancel something, as you can see here. I'm doing that. And I'm having m plus n and n minus m. I would like to have m minus n instead. So I am having half m plus n times m minus n if I kick minus in front. So what we're getting is minus a half m squared minus n squared, which is n squared minus m squared divided by 2. And so let's do the last one for today. We're going to show that the limit x towards 0, tangent of x minus sine of x divided over x cubed. Well, what would that be? Let's see. We can write it down as limit x towards 0. Let's kick 1 divided by x cubed in front. And sine of x, tangent of x is sine of x divided over cosine of x minus sine of x divided by 1. All right. So that would be limit x towards 0, 1 divided by x cubed. We have sine of x minus sine of x times cosine of x divided over cosine of x here. I just bring it to the same denominator. Now you see we have a common factor, sine of x. We can kick it outside of the parentheses. So we are basically having a limit x towards 0. Now see what I'm doing. I'm having 1 divided by x cubed. I'm writing it as 1 divided by x squared. I'm kicking sine of x outside of the parentheses. I kick one of the x cubes, so 1x out of x cubed here. And what we still have is 1 minus cosine of x. 1 minus cosine of x divided over cosine of x. Is that right? Let me check. Yeah, that seems to be fine. So if you remember, this one is going to be 1. So we're almost done with that. What should we do with the second one? Well, we're having 1 minus cosine of x, and we would like to handle it. Let's see. So we know that the cosine squared of 2 alpha, this is cosine squared of alpha minus sine squared of alpha. So that means, and also, of course, cosine squared alpha plus sine squared alpha is giving me 1. So I can rewrite it. Sine squared is just 1 minus cosine squared, or cosine squared is just 1 minus sine squared. I do not care actually. But let me solve it maybe for what I'm doing. I'm substituting cosine squared as 1 minus sine squared of alpha. So I'm having 1 minus 2 sine squared of alpha here. And that means I can rewrite it. Is it right what I'm doing? Well, I would like to go, my bad. Yeah, it's not right. I'm sorry. This is just cosine of 2 alpha only. Now it's fine. Okay, now it makes more sense also to me, which is always a good sign if your tutor understands what he's doing. So cosine of 2 alpha is 1 minus 2 sine squared of alpha. And we have basically, as you can see, 1 minus cosine of x. So 1 minus cosine of 2 times x divided by 2 is 1 minus, and now instead of cosine of 2 alpha, we're bringing this one. So we are having 1 minus 2 sine squared of x divided by 2. So 1 and 1 are gone, and we're just having 2 sine squared of x divided by 2. So this is how we can substitute 1 minus cosine of x. All right, so let me do it in the next step. We have limit x towards 0. So let's maybe put sine of x divided by x just separately here. And then we multiply it times the limit x towards 0. So what do we have? We have, instead of 1 minus cosine of x, we're using now this formula. This is 2 sine squared of x divided by 2. This is what we have here. And we are dividing it by x squared. And then we have one more limit, which is actually also almost done, as x is approaching 0 of 1 divided by the cosine of x. All right, so 3 limits. Only can separate them, the product, if we know that those 3 are actually existent. We know that this is 1. What is happening here? Well, once again, we can split it. We can take 2 in front. We're having limit x towards 0. We're having sine of x divided by 2 divided by x times sine of x divided by 2 divided by 1 more x. And the last limit, as x is approaching 0, it's 1 divided by the cosine of 0, which is 1. So this is 1 divided by 1, which is 1. Now you see we're missing 2 here. So, and also here. If I'm doing that, I have also to multiply times 2 here and there. That means I'm dividing by 2, so this one is canceling with that one, and this one is not canceling, so we're kicking it in front of the limit. This is giving me 1, this is giving me 1, and a half is coming in front of the computation. So the value is 1 divided by 2. I hope, guys, you got some new ideas. and see you in the next videos. Bye bye.